Okay, say anybody from 12th class, this is not for 10th standard. Okay, I can see many names that you have attended my 10th class, right? So anybody from 12th. So this video, today's video is exclusively for 12th students. Okay, you can be of any board. It can be a CBSE board or state board or any state board, okay, who is following NCERT textbooks. Okay, Girish, hi, Devraj, S, okay, okay. So 12th board students are there. Very good, very good. Hi, HH. Hello, hello, Shashikala. Hi, good evening. Hi, Devraj is in 12th. Okay, fine, very good. Okay, hi, hi, Pranam, Zoya, Surendra Kumar, Sinchana, Amruta is in 11th, right? Okay, fine. Jagadish, Mohita, Lavanya M, Girish, Arya. Okay, very good, very good. So very nice. Okay, so today I am going to talk few things about alkyl halides and aryl halides. So already that chapter is there in our channel. Hope you all have watched the videos. Everyone watched the videos. So just reply me whether you watched the videos or not. Thank you, Sindhu. Lots of love from my side also. Thank you so much. Bindu, yes, okay. So you watched the videos, right? Okay. Fine, fine. So based on the concepts that I told in the video, let me discuss a few questions today. Okay. So the way the questions can be asked for competitive examinations. So how many are preparing for competitive examinations here, like NEET, JEE, CET? How many are preparing for those competitive examinations? Thank you, Indira. Okay, so Shri Kartika is preparing for NEET. Okay, fine. So where are you guys from? So can I know your place? Where are you from? Which place are you from? Okay, CET. Girish is preparing for CET. Okay, fine. Tamil Nadu. Oh, Karnataka, Mangalore, JEE Advance. Okay, Karnataka. Fine, fine. So most of you are from southern states, right? Andhra, Tamil Nadu, Karnataka. Okay, very good, very good. So fine. See, Karnataka board definitely, you know, it follows NCERT textbooks. So no need to worry. And other boards also, even Andhra or Tamil Nadu, almost even they follow the NCERT content only, because the NEET examination is common for all over the India, right? Okay, so Jammu Kashmir students are also there. Very good, very nice. Fine. So because the NEET and JEE is completely on NCERT based, so it is better to follow NCERT textbooks. I recommend you to follow NCERT textbooks, everyone. Okay, fine. Okay, sure. So today let me give you the way questions can be asked from this alkyl halides and aryl halides. So let's just start. We have studied nucleophilic substitution reactions in alkyl halides and aryl halides along with the mechanism in a very detailed way, right? So can you all tell me which are the two types of mechanisms we studied under nucleophilic substitution reaction? Which are the two types of mechanisms we studied in nucleophilic substitution? Yes? Two types of mechanisms in nucleophilic substitution. Very good, very good. So we studied SN1 and SN2 mechanism, right? So SN1 mechanism was a two-step mechanism and SN2 mechanism is one-step mechanism. And there, here I am not going to explain how the mechanism goes on and whatever it is. So I am just exposing you the way questions can be asked on this particular topic. Okay, fine. So we studied very important point here. For SN1 substitution reaction, tertiary alkyl halides were more reactive than secondary, secondary were more reactive than primary, right? And here we studied opposite, that is primary alkyl halides were more reactive than secondary, secondary were more reactive than tertiary, right? So based on this point, questions can be asked for the competitive examination. Okay, so this is a very important point one must remember from SN1, SN2 substitution reactions, guys. Okay, and look at this question. So this is one alkyl halide and this is another alkyl halide. Okay, so let me call this as 1 and this is called, this as 2. And tell me which one can undergo SN2 in a better way, right? So answer to my question, which one can undergo SN2 in a better way? SN2 substitution in a better way. Yes? 1 or 2? Yes. So you people are answering. Very good. Okay. So it is 1. Compound number 1 can undergo SN2 better. Can you tell me why this undergoes SN2 better? Yes, because this is primary and this is secondary, right? So primary alkyl halides always undergo SN2 reactions in a better way, right? So these are actually very simple but yet very important model for the competitive examinations. Okay, so this way they'll give different series of compounds and they'll ask you to arrange in an increasing order or decreasing order. This is a kind of one important concept, right? And one more question here, one more question. So just tell me if I have a compound something like this. Okay, so I have an alkyl halide something like this. Tell me whether this undergoes SN1 better or SN2 better. Okay, so this is the compound, this compound. So tell me whether this undergoes SN1 better or SN2 better. Okay, look at the compound carefully. It's not like a normal organic compound, right? We call them as bridged head compounds. Okay, so bridged compounds. You have bridged carbons there. Okay, so some of you are actually telling me SN1 and few are like SN2. Remember guys, this will never undergo nucleophilic substitution reaction. Okay, no SN1 and no SN2. Okay, so such bridged carbon containing compounds will never undergo SN1 and SN2. Remember. So are you all clear with this? So this kind of compounds will not undergo anything. They won't undergo any nucleophilic substitution. So no SN1 and no SN2 also. Okay. And here Lavanya M is actually from class 11, right? Yes. For class 11, I will take live session. I'll inform when I am coming live for class 11. Okay. Now this is only for class 12. Fine. So are you all clear with this concept? Everyone? Okay. So this is one important example, guys. So such compounds which have a bridged carbon, they'll never undergo nucleophilic substitution reactions. Okay. So this is one concept that you should know. Fine. And now look at these compounds. So very important compound. Okay. So look at this. Look at these compounds, CH2Cl. Okay, so both of them, tell me whether they undergo SN1 better or SN2 better. Okay, so you have two compounds on a board. So which one undergoes SN1, which one undergoes SN2, or both of them undergo SN1 or both SN2 or none. Okay, so you just have to reply me. So what about these compounds? So Devraj, Viru, most of you are telling me that they undergo SN1. Okay, so actually speaking, this is allyl, right? So this is allyl halide. This is allyl halide, right? So why do we call it as allyl halide? Because this carbon is there, no, this is a allyl carbon, right? So you have this carbon's hybridization sp3, this is in turn attached to unsaturated carbon, right? So such a carbon is called allyl carbon, so this is allyl halide. And similarly, this is actually benzyl halide. This is benzyl halide. You know, both allyl halides and benzyl halides can undergo SN1 and SN2. They undergo both of them. They can proceed through SN1 and they can also proceed through SN2. But SN1 is excellent with them. Okay, so among SN1 and SN2, if I ask you, definitely you have to go for SN1, because in SN1 mechanism, formation of carbocation takes place. Suppose if this is a carbocation that is formed, okay, though it looks like a primary carbocation, this carbocation can be stabilized by the resonance. Okay, so though it looks like a primary carbocation, the carbocation is stabilized by the resonance, guys. So that is the reason SN1 happens in an excellent way with allyl halide and benzyl halide. But remember, allyl and benzyl can go through both mechanisms. SN1 is possible, SN2 is also possible, but excellent way is SN1 because their carbocations are stabilized by the resonance. Okay, fine. So are you all clear with this concept? Very, very important concept. Okay, you should know with allyl and benzyl. Okay, so how their carbocations are getting stabilized, why I am telling SN1 in an excellent way. Okay, so the entire concept is important, right? So this is one such thing which you should remember. And now I have very interesting example from NCERT book. Okay, so observe it carefully. CH3, CH, CH3, CH2, CH2, Cl. And the other one is CH3, CH2, CH2, CH, 1, 2, 3, 4, right? Okay, so let me put the CH3 here and CH2, Cl. Okay, so you have two compounds on a board. Tell me which one can undergo SN2 in a better way. So among the two alkyl halides, which one undergoes SN2 in a better way? Yes, compound 1 or compound 2. Very good. Viru is answering very nicely. Very good. So this particular compound, look at here, both are primary. Look at here, this is a primary carbon and this is also a primary carbon. So you would get a doubt that both of them undergo SN2 in a better way, but it's a comparison, right? I'm asking which one undergoes excellent with SN2. Okay, so definitely it is the first one. Why? Because crowd around the carbon, crowd is there, but you know the crowd is very far. Crowd in the sense here branch. Okay, so this methyl group is very far here. It is not disturbing carbon because in SN2 nucleophile must go and attack from backside, no? So if a nucleophile has to go and attack from backside, crowd should not be there. Steric hindrance should not be there around carbon. Okay, so here CH3 is very far away. So nothing is there here to disturb this carbon, to disturb nucleophile to go and attack. But here, look at here, this CH3 is very near to this primary carbon. Okay, so here somehow the nucleophile finds difficult to go and attack to this carbon because you know lots of crowd, right? So you have to see the distance of the branch also. So if the branches are very far, you know, then it is safe for SN2 mechanism. Okay, so distance of the group also matters a lot, guys. So you have to be careful with this point also. Okay, fine. So this is all about like SN1, SN2 things. And now one more interesting example here. CH3, C double bond O, okay, CH2, Cl, CH3, C double bond O, okay, CH, let me put it this way, Cl, CH3. Okay, let me change here. CHCl CH3. Okay, so look at these examples. It's like both are secondary alkyl halides. Okay, so both are secondary alkyl halides, guys. And you tell me which one undergoes SN1 reaction, or you can commonly tell me whether they undergo SN1 or SN2. Okay, so my question here is whether these things, both are same here, right? Okay, so both are same here. You just tell me whether this compound undergoes SN1 or SN2. Okay, so both are same here, there is no difference. So whether they undergo SN1 or SN2, that is my question. Okay. Yes, many of you are telling that it undergoes SN1. Okay, so let me just check it out. Viru said SN1, Narayan said SN1, Aditya, okay, good evening, very good. SN1, everybody are telling that it is SN1, but no, SN1 is not at all possible with this kind of a compound. Okay, SN1 is not at all possible. It's quite a deeper aspect, but you should have clarity on this aspect, guys. Question was asked in one of the NEET year. Okay, I don't remember which year it was. So this particular example was asked. Okay, see, this will never undergo SN1, SN2. It can go for SN2, but not SN1. Why? Because look at this guy. This is electron withdrawing group. Okay, so that C double bond O is electron withdrawing group. Okay, so when there is an electron withdrawing group, tell me how can a carbocation that is formed here is stable? Yes or no? See, in SN1, this is the carbocation you will get in the intermediate. Okay, see, the carbocation must be stable, no? For the further step of reaction to happen. But this is electron withdrawing group. Electron withdrawing group decreases the stability of carbocation. This may be a secondary alkyl halide, but the carbocation that is formed here is unstable due to the presence of this electron withdrawing group, guys. Okay, so that is why definitely it will not proceed through SN1. So better option is SN2. It will undergo nucleophilic substitution, but it is always through SN2. Okay, it is because this is a electron withdrawing group. So always you have to check whether there are electron withdrawing groups or not. If there is an electron withdrawing group immediately next to the carbon that is bearing halogen, then definitely don't go for SN1. Okay, so you should go for SN2. Clear? Fine. So this is one more important concept, guys. So this is all about SN1, SN2. So these comparative questions are very, very common in the examination. Okay. And one more last example. Look at here. Tertiary butyl. You have tertiary butyl chloride, tertiary butyl iodide. Okay. Can you tell me which one undergoes better SN1? Okay, so among, okay, let me call this as 1 and this as 2. Among 1 and 2, which one can undergo better SN1? Better SN1. As Narayan has answered, I'm asking which one better, 1 or 2. You just have to tell whether it is 1 or 2. Yes? Which one undergoes better SN1? Very good, very good. Most of you are answering iodide. Okay, so tertiary butyl iodide undergoes better SN1 because always remember, guys, it can be SN1 or SN2. Always alkyl iodides are more reactive than alkyl bromides, and then alkyl chlorides, and then alkyl fluorides. Okay, so alkyl iodides, because iodine is a best living group, guys. Okay, iodine, since it's bigger in size, this bond you can break it very easily so that iodine can go out very easily. So it's a better living group, right? So that is why that is the order. Clear? Fine. So that's all about SN1 and SN2 here. Very, very important. Fine. And after this, you have so many examples for nucleophilic substitution reaction, right? So all examples are very, very important. Like two important examples I'll show. Suppose you have Rx. I treated with alcoholic AgCN. Rx is there. I will treat it with alcoholic KCN. Tell me what type of organic compounds you will get in this case. So this is reaction 1 and this is reaction 2. In case of reaction 1, tell me what type of organic compounds do you get in case of reaction 1. Quick. In case of reaction 1, what type of compound do you get? Is it cyanide or isocyanide? Okay, it's AgCN. It is AgCN and this is KCN. Yes, few are answering. So with AgCN, you will get RNC. Okay, can you tell me why do you get RNC here? But here you will get RCN. So here you are getting isocyanide, right? And here you are getting cyanide. Tell me why do you get isocyanide here? What is the reason for isocyanide? Reason is also very important, guys. Reason is also very, very important. Why are you getting isocyanide in case 1? Why are you getting isocyanide in case 1? Viru Gowda, ambident nucleophiles, that is not the reason. Okay. See, AgCN is covalent. AgCN molecule is covalent. Okay. KCN molecule is ionic. Since this fellow is ionic, it will break down into K plus and Cn minus. I mean, the negative charge is there on carbon. So this is your nucleophile. So bond is always between this carbon and R. That is why you are getting Cn. You see, the bond is between carbon and carbon. Carbon of R and carbon of Cn. Okay, because this fellow is ionic, it is breaking down into K plus and Cl minus, and this minus charge is on carbon. So the link is between carbon and R. Whereas this fellow is covalent, guys. Covalent in the sense, it will not break down into Ag plus and Cn minus. No, that will never happen. Okay, so AgCN bond is covalent. So here reactive center is the lone pair present on nitrogen. Okay, so now suppose if this is Rx, the lone pair on nitrogen is the reactive center, and now X goes outside. So the bond is between R and N, guys. Okay, so that's why you will get NC here. Okay, so reason is very important. Because this fellow is covalent, you are getting NC. Because this is ionic, you are getting Cn. Okay, so is the concept clear? This is one of the very important concept. Okay, right? Very good, very good, very nice. So this is one aspect. And now very, very interesting example. I have CH3, CH2, Cl. Okay, and I'll show two reactions here. Two reactions I'll show. One is alcoholic KOH, the other one is aqueous KOH. Okay, products are different. Alcoholic KOH will always act as a base, aqueous KOH will always act as a nucleophile. Okay, so tell me what is the product A. Let me take this product as A and this product as B. Tell me the IUPAC name of A. Tell me the IUPAC name of A. So what is A and what is its IUPAC name? Look at the reagent, alkyl halide. To that I have added alcoholic KOH, guys. Okay, so most of you have answered. So it is ethene, CH2 double bond CH2, right? So this is ethene. Okay, and here CH3, CH2, OH, that is ethyl alcohol or ethanol is the IUPAC name, right? So this point of difference is very, very important. So whenever you use alcoholic KOH or NaOH with alkyl halide, you get elimination reaction. Here you will observe elimination reaction, and here you will observe substitution reaction. There elimination, here substitution. Okay, so this is very important. And now, fine. See, the concept that I tell next is very, very important. Competition between elimination and substitution. When do you decide? Okay, if the reagent is alcoholic average, okay, you write elimination product, and aqueous, you write substitution product, right? But if the reagent is, observe carefully, if the reagent is, suppose I have CH3, CH2, Cl, look at the reagent, guys, look at the reagent, okay? If I have CH3 thrice CO minus K plus, okay? Fine, if this is the case, tell me whether elimination takes place or substitution takes place. So, competition, I am talking about elimination versus substitution. You know, in our NCERT textbook, there is a small box. Okay, so there is a small blue color box, elimination versus substitution. Most of them will neglect that box, but that is very, very important. Okay, so that is very, very important. So you must know when you have to go for elimination, when you have to go for substitution. Okay, if the reagents are something like this, you should have an idea when to go for elimination, when to go for substitution. Yes, what happens here? Yes, most of you have answered, it's elimination. Okay, so it's elimination reaction. Can you tell me why not substitution? Okay, why not substitution here? Why do I get elimination? Why do I get elimination reaction? Yes? So on what condition you will actually decide whether it is elimination reaction or substitution reaction? Can anyone tell me on what condition you will decide whether there is elimination going to happen or substitution going to happen? Yes? Anyone? I'm just waiting for your answers. On what basis you will decide whether elimination happens or substitution happens? Yes. See, usually if the base is sterically, you know, it's a very much complex base. I mean, okay, let me not use too much scientific words. See, it's very much complicated base. It's too much branch, too much of crowd is there, right? Too much of steric hindrance is there. Then in that case, you just think, how can it go and attack, it should go and attack, this particular carbon, right? So when it is so much heavy, so much complex, it feels very difficult to go and attack. So that's the reason here elimination predominates. Elimination always predominates, and you will get CH2 double bond CH2. Okay, so when the bases are very simple like OCH3, okay, suppose I have a reaction CH3, CH2, Cl, okay, above the arrow mark I have OCH3 minus, okay, so I have this, let me take this Na plus OCH3 minus, okay. So now tell me whether elimination or substitution. Here what will happen, substitution or elimination? Yeah, here definitely substitution reaction. Okay, see, base is very simple, you know, this is what the nucleophile that can be generated. So this fellow attacks this carbon, Cl goes outside. So you will be getting CH3, CH2, OCH3. Okay, so you will get ether. So in this kind of substitution, you are going to get ether. Okay, so look at this. So complex bases, you know, too much of branched bases, when you have, always write elimination product. If the base is very simple like ethoxide, methoxide, OH minus, halide, S minus, SH minus, for all of them you can go for substitution. Okay, so this is also one of the very, very important aspect, and read that small paragraph that's there in NCERT textbook. Okay, so that's very, very important, don't neglect. So after substitution reactions, you have a small box in NCERT, read now, fine. So this is what I can discuss today, okay. I may not cover all the concepts, just I have focused on the most important concept that was frequently asked from alkyl halides and aryl halides. Still, the concept is huge. Okay, so we cannot dedicate that much time to cover such huge concept in one single class, isn't it? Okay, and one more thing what I wanted to tell you is I am launching a very beautiful course, okay, that is in the next month. The course is all about organic chemistry. I have completed, I have covered all the 7 organic chapters. Okay, so all the 7 organic chapters, that means part 2 textbook completely I have covered in a chapter. See, what you will find in a course is detailed concept clarity. So I will go to every concept in a depth, okay, very detailed way, with lots of questions for the practice, and I will give you my handwritten notes for all the chapters. I am giving you the handwritten notes, okay, in a simple form, in a shortcut form. Not only that, I am solving all the NCERT questions. So in NCERT textbook, all in text and all exercise questions I will solve, and on every chapter I will be giving you 50 questions. And those 50 questions majorly I picked from previous years. Okay, previous years most repeated concept is there, no, on that I framed out a question. So this is what the course includes, guys. Okay, so you will have all the concepts covered in a very detailed way. Okay, each and every concept, each and every line of NCERT, and outside the NCERT also few reactions along with the mechanism. Speciality of this course is every reaction I thought along with the mechanism. Okay, because only then you will get the confidence to attempt any question in the exam. Okay, it was thought in a very different way, in a particular way, you know, as I told you, complete notes is available, complete concept clarity, and all NCERT exercise in text questions completely solved. Along with that, on every chapter 50 practice questions, and you have solutions on those practice questions also. Okay, this is the course, and the fees and everything I will inform next month when I launch the course. Okay, so I just gave this information for you. So whoever is interested, you can just comment in this particular after this video. Okay, and likewise I'll be completing all physical and all inorganic also. Okay, so after this organic I'll be completing physical 5 chapters, the most important chapters: solid state, solutions, kinetics, okay, and all of that. See, this course is for those students who are so much interested to crack the competitive examinations, but you don't have a source, right? You are interested but do not have a source. For those children, this is very much helpful. So in your colleges, if the teachers are not good, I mean, if you are not understanding your teachers' teaching, if you are confused with the concept, somewhere the clarity is missing out, you know, for those students, right? And also this course is helpful for the teachers who are starting their career, okay, newly started teachers. Okay, even for them lots of confusions would be there, like which to be taught, which not to be taught, and which one should be taught in a better way, you know, all that. Okay, so this course is for teachers, okay, newly career started teachers, and the course is for the students who definitely want to crack competitive exam, where if you are concentrating chemistry to improve your score, if you want to you know, have a concept clarity in organic chemistry, or for the students who do not have a proper teaching at the college. Okay, somewhere if you are missing out a clarity on the concept, you know, 3 category people are eligible to take up this course. Okay, so more details about the course I'll be telling in the next month, right? Fine. So okay guys, tell me which chapter do you want me to teach next. I mean, don't think that madam will start teaching in the YouTube. No, in the YouTube I'll continue teaching. Okay, so but not in a very detailed way, because I cannot spend so much of time to tell every bit in a detailed way. It takes lot of time, but I'll definitely help you out with the important concepts in the YouTube. Okay, so tell me, you have to tell me which chapter you want next. Which chapter? Physical chemistry. Okay. So, shall I start with solutions or solid state? Which one you want? Solutions or solid state? Okay, we'll go for solutions because majority of the colleges solutions chapter is over. They'll start with solutions chapter, isn't it? Okay, I'll go with solutions chapter next. Okay, fine. So all the best. With this, I'll end the session. Hope you had got some new points from the video. Did you get any new points from the video? Anybody? Anybody? Just tell me. Did you learn something new? At least 1 point new from the video? Yes, very good. Very good. Okay. And all my videos will be like that. At least you will learn 1 new point. Okay. So that is very, very special for competitive exam. Very good. Okay guys, thank you so much. All the best. Keep learning. Okay. Good night.